Alright, in this video we're going to pick up with our Unit 1 Intro to Functions review with question 7 from the review packet, which is asking about finding inverses. So, our job is to find the inverses of the following functions. So remember, to find an inverse, my main goal is to switch my input and my output. So whatever I have to do to make that happen, I have to switch those. So in this function, my original function f of x has an output f of x when I plug in x. So my first job is to switch those two terms. So the x will move to the outside, and f of x will move to the inside everywhere that x used to be. But once I put it inside, I change the notation to show that now I'm looking at the inverse. So the f of x moves to the inside in inverse notation, f negative 1 power. And everything that was happening to x now happens to f inverse. So negative 2 being multiplied, 24 being added, and the 4 in the denominator. This is my inverse equation, but I do have to simplify it. Now that I've rearranged this, I do have to tidy up. So I do have to get this f inverse term alone. And the way that we're going to do that is we're going to figure out what's happening to it so I can undo it in the opposite order. Again, if you need to use a list to do this, it can be very helpful. So the first thing happening to f inverse of x in the order of operations is that it's being multiplied by that negative 2. So times negative 2. The next thing happening is the rest of the numerator, which is at plus 24. So those have to happen together before I take into account this as a fraction. So the last thing that happens is that I divide by 4. My job is to do those in the opposite order and to undo them instead of doing them. So I'm going to use the opposite operations in the opposite order. So for step 3, instead of doing divided by 4, I'm going to do a times 4 to undo that. Instead of plus 24, I'll do minus 24. And instead of times negative 2, I'm going to divide by negative 2. So if I do these 3 steps in this order, I will have my f inverse alone. So the first thing I'm going to do is multiply both sides by 4. So times 4 here and times 4 here. That's going to give me 4x. And on this side, my 4's will cancel, and I'll have negative 2 times the inverse of f of x plus 24. Up next, I'm going to have to subtract 24 from both sides. Minus 24 there, minus 24 there. That gives me negative 2 times the inverse of f of x left on the right. And on the left, I have 4x minus 24. The last thing I have to do is divide both sides by negative 2, here and here. So it gives me f inverse by itself, and my inverse function is 4x minus 24 over negative 2. You can continue simplifying this, but for our purposes it's unnecessary. We're going to go ahead and call this our final answer for the inverse function. As long as f inverse is by itself, I can be happy that we're done with that. Up next, let's find the inverse of g of x. So again, we have to switch our input and our output. Our input is x, our output's g of x. Let's go ahead and switch those. X is on the outside, and g of x is now on the inside with the 2 and the plus 3. And since I've switched them, I'm going to go ahead and call it the inverse of g of x. Now all I have to do is get g of x alone, so we're going to figure out what's happening to this term right here and how can we undo it in the opposite order. So the first thing that happens to it inside that radical is that it is being multiplied by 2. Up next, we have to add that 3. And the very last thing that happens to it is that square root. That's grouping everything together, and everything is inside of it, so everything is happening before the square root happens. Our job is to undo those in the opposite order. 3, 2, 1. Instead of a square root, I'll use the opposite, so I'll do a little exponent 2. Instead of plus 3, I'm going to do minus 3, and instead of times 2, I'm going to divide by 2. So my first job to unwrap x is to take both sides and square them. So I'm going to take this side and square it, and I'm going to square this side as well. So I end up with x squared, and on this side, my square root and squared cancel each other out. They're both gone, and all I'm going to have is 2, the inverse of g of x, and the plus 3. Then I can subtract 3 from both sides. I get x squared minus 3, and I have 2 and the inverse of g of x here. And then the last thing I do is divide both sides by 2. So it gives me g inverse by itself. And on the other side, I had x squared, I had minus 3, and that whole thing was being divided by 2. That is the inverse. Let's go ahead and try example C. Now C is multiple choice because C takes things one step further and continues simplifying. So if it wants you to continue simplifying after you've created your inverse equation, this is probably what the question is going to look like. It's going to give you options to choose from. So I'm going to go ahead and find the inverse first, and we'll figure out how it simplified it. So I'm going to take my input and output and switch them. Input is x, output is w of x. So x equals -3 times the inverse plus 12. My job is to get this inverse alone. So I'm going to go ahead and say this is being multiplied by -3 and added to 12. So I need to undo those in the opposite order. I need to subtract 12 and divide by -3. So that means, kind of messy, I need to subtract 12 from both sides. Let's go ahead and do that. Minus 12 here, minus 12 there. I get x minus 12. And on the side, -3 times the inverse. And the last thing that happens there is that I divide both sides by -3, which is usually where we would leave this. But the inverse that I get, w inverse of x, x minus 12 over -3, doesn't match any of the options listed because all of my options have continued simplifying. So what they've done in these options is they have actually divided by -3. Now, just like I can take my entire numerator and multiply it by a number by distributing whatever I'm multiplying, I can take my entire numerator and divide it by a number if I distribute my division. So that means that my inverse is actually made of x being divided by -3, and I can subtract 12 being multiplied by -3. So let's go ahead and see what that looks like when I divide it. Now all of these options have 1/3, almost all of them have 1/3 times x. And if I take my x and multiply it, divide it by -3, it's the same thing as multiplying it by -1/3. It just means I have to find 1/3 of whatever x is and change its sign to the opposite side. So -1/3 x is going to be part of my answer. And the only other thing I have to simplify is this over here, -12 over -3. 12 divided by -3 is -4, but I have to subtract a -4. It's going to turn into a positive. Just like when I multiply, when I divide a negative and a negative, I end up with adding a positive. So -1/3 x plus 4. So I had to figure out that I could divide both of those terms. And once I've done that, I can see that option 3 is my answer. I have the -1/3 with the x, and I've divided the 12 by -3 to get that positive 4 as well. All right. Now that we're done with that, let's go ahead and take a peek at question number 8. Question 8 is asking for a rate of change again. So we have this table, and we'd like to calculate the rate of change based on this table. Now this table is measuring days, and it's measuring temperature. Now the temperature relies on what day and time and all that I measure it. So my days are going to be my inputs, and my temperatures are going to be my outputs. And I have a couple different temperatures here based on the city. So the first question says, find the rate of change of the temperature in Orlando. So for Orlando, I'm only going to focus on the y values at the bottom of this table, these f of x values. And it wants me to find the rate of change from Tuesday to Sunday. So this is my interval here. And I have to find some way to turn this into numbers. So what I can do is just number the days of my week. So Monday is the first day of the week. Tuesday is 2, Wednesday is 3, 4, 5, 6, and 7. So my job is to figure out the rate of change from Tuesday to Sunday. So that's here to here. So from 2 to 7. So my interval is from 2 to 7, the second day to the 7th day. That means that 2, Tuesday, that's my A value, and 7, Sunday, that's my B value. And that's going to let me use the rate of change formula, which again is f of b minus f of a over b minus a. So my denominator is just going to be b minus a, 7 minus 2. My numerator is going to be f of 7 and f of 2. So to find f of 7, I look for my Orlando output on the 7th day, which is 91 degrees. And for f of 2, I have to look at the Orlando temperature, the output, on the second day, Tuesday, and that's 94. So 91 minus 94 over 7 minus 2. So 91 minus 94 is -3, and 7 minus 2 is 5. So as a fraction, it's negative 3 over 5. But the directions do say to round your answer to the nearest tenth. That's the only other time you have to use decimals in this class, is when the directions specifically say that you should. And if you plug this in the calculator, you're going to get negative 0.6 for our decimal, rounded to the tenth place. The last thing we have to make sure to do is indicate units. My numerator was measuring temperature, and the temperature is being measured in degrees Fahrenheit. My denominator, 7 minus 2, those were counting days. So this is measuring days. So degrees Fahrenheit per day. So what this rate of change means is that my temperature is decreasing by 0.6 degrees Fahrenheit per day. So the negative tells me I'm going downhill by negative 0.6 degrees per day. The next question says to find the average rate of change in San Francisco. So this time I'm using a different part of my graph. Instead of Orlando, I'm going to be using the information for San Francisco, and I'm going to find the rate of change for the temperature from Thursday to Saturday. Now I've already measured my x-axis with numbers, so now I'm looking Thursday to Saturday. That's my interval. So again, my A value is going to be 4 to the 6-day Saturday. So from A to B, from Thursday to Saturday, 4 to 6. That tells me my denominator, 6 minus 4. To find my numerator, I have to do f of 6 minus f of 4. F of 6 is the number 96, because again, we're looking in the San Francisco column, 96. And f of 4 is going to be the output here on Thursday, which is 102. 102. Now we're ready to go ahead and calculate this rate of change. So 96 minus 102 is negative 6. My denominator, 6 minus 4, is 2, which gives me the rate of change of negative 3. It says round to the nearest tenth if necessary. This is a whole number, so it's not necessary to round, but I do still have to indicate my units. And they're the same units as before. I had degrees Fahrenheit on top, and I have per day in the denominator. So this temperature in California is changing by reducing, it's going down by 3 degrees per day on average. We're going to go ahead and pick up with question 9 in the next video.